Hello everyone and welcome back. In today's lecture we are going to study about the point function and path function. First let us see the point function. Point functions are those for which the change depends on only the end states and not on the path followed. That means the property of a system which does not depend on path of process but depends on end state is called point function. Let us understand this with the help of a PV diagram. On the x-axis we plot the volume and on the y-axis we plot the pressure. Now if I consider a state 1, now at this state I require two properties, that is one is pressure P1 and another is volume V1. So this pressure and volume is considered as the point function because they are only depend on the point. They are not depend on the path of the system or a process followed. Now this is the state 2. Again at this state I require two properties, that is pressure P2 and volume V2. Similarly, to plot the TS diagram we should know the properties like temperature and entropy. So even temperature and entropy are considered to be the point function. Remember, the thermodynamic properties of system change with state of the system and it is independent of the path of the system. Or we can also say that it depends only on the initial and final state of the system. Now for example, we need to find the volume difference. So we can simply find it out by subtracting V1 from V2. That is V2 minus V1 will give you the change in volume. Now the differential of point functions are exact or perfect differentials and the integral is simple. That means the integral of dv will be with respect to v1 and v2 is equal to v2 minus v1. So they are called as the exact differentials. So if we want to find change in volume, we are only concerned with the end state and not with the path which it is following. Let the path be straight, curve or zigzag, any path let it follow. We are not concerned with it. We are only concerned with its initial and the final state. So that by knowing the initial and the final state, we can find the volume difference or change in volume. Same is the case for the pressure. So all the thermodynamic properties like pressure, volume, temperature, entropy, enthalpy, all these are considered to be the point functions. Now let us see the path function. The curve which joins the initial state and the final state is called the path. So we can define it as path functions are those for which the change depends not only on the end states but also on the path followed. That means there are certain quantities which cannot be located on a graph by a point but are represented by the area on that graph. We saw that pressure, temperature, volume are located on the graph by points, but some properties are not able to locate on graph by points but are represented by area on that graph. So to understand this, again I have plotted the pressure and volume PV diagram. I have plotted. In that there are two states representing the state 1 and state 2. Now the curve which joins these two states, state 1 and state 2, I'll represent it by the path P. Alright. Now the area under the curve, this area which is below the path P, it is considered to be the work done. Similarly, if the process is joined by path Q, then this area is considered to be the work done. Or if it is following the path R, then this area is considered to be the work done. So by this figure you can see that as the path varies, the work done by the process will also be changing. So if it is following the path P, this much work done will be given, or if it is following the path Q means this will be the work done. Of if it follows the path R, then this will be the work done. So as the path changes, the work done is increasing. Similarly, it is if we plot the TS diagram, we can get the heat transfer. So the quantities which depend on the path of the process are called the path functions. So work and heat are the path functions. We also say that they are inexact differential. Why inexact differential? Because we cannot find the work done by W2 minus W1, because work done is area under the curve. And you can see from the graph, if it is following the path Q, the work done will be increased, and if it is following the path R, then the work done will be more than the path P and the path Q. So we say that path functions are inexact differential. Mathematically, we can write it as integral of delta W will not be equal to W2 minus W1. It is inexact differential. So we have to write it that W1 to 2. This 1 to 2 is the process which it is following. Okay, so work is dependent on the path it follows. Again, same is the case for the heat transfer. So delta Q will not be equal to Q2 minus Q1. We have to write it as Q1 to 2. So we say that work and heat are the path functions. Let us compare the point function and the path function. Any quantity whose change is independent of the path is known as point function, whereas the quantity which depends on the path followed is known as path function. The magnitude of point function depends on the state, whereas the magnitude of path function is equal to the area under the curve. Point functions are exact differential and denoted by D, whereas path functions are inexact differential and denoted by delta. Pressure, volume, temperature are some of the examples of point function, whereas heat and work are considered to be the example of path functions. Hope with this you might have understood the difference between the point function and the path functions. Thank you for watching the video.